Hi, everybody. Today is Tuesday, September 22nd, and you are all at the Kubernetes SIG Testing bi-weekly meeting. I am your host and chair, Aaron Drickenberger. We're all going to be adhering to the Kubernetes Code of Conduct during this meeting, so you can watch yourselves not be jerks. As this meeting is posted to YouTube later today, since it is being publicly recorded. And if anybody feels like someone is being a jerk or needs to report the code of conduct, conduct at kubernetes.io is the place to do that. So I posted a link to the agenda in chat. I'll do it again for folks who just showed up. First off, I appreciate everybody who showed up, because that means you used the new link, or my calendar update got to you, or you just generally heard about how every meeting in the community now has a passcode. So thank you very much for paying attention. If you know somebody who should be here who's not, let them know. The only thing I had on the agenda to discuss today was to just kind of review where we're at with the Kubernetes CI policy thing that we talked about a while ago. And then we don't really have much else. So I'm happy to talk about whatever folks want to talk about, or shut it down early if we have nothing else to discuss. So I guess I'm going to try and just share my screen. Let's see if I can do that. Share the application. I'm going to share that one. Okay, so apparently I cannot see video while I'm doing this. I'm toying around with using the Chrome app so I can use this on my work computer. But so this is the project board for all of the CI policy things. I'm going to see if I can find my way to the umbrella issue to remind everybody what we're talking about and why. So there was a policies to improve Kubernetes CI proposal that we discussed here earlier, and it basically involved things seemed really bad during the 1.19 code freeze. It seemed like that was both a combination of resource exhaustion and also just tests being really flaky in general, which the resource exhaustion was making worse. So as a result, this was one of the reasons that the V1.19 milestone was left in place, or like code freeze was left in place all the way until 1.19 was released. And this is the reason the V1.20 milestone restriction was also left in place, so that the gigantic backlog of PRs that were ready to merge into V1.20 could actually merge by people sort of piece by piece adding the PRs into Tide's pool and ensuring that that could all merge. We decided there were a couple of things we wanted to do as policies going forward to allow more productive merging of PRs. The main things centered around was actually declare the resources that we think all of our jobs were using. As it turns out, all the jobs were not declaring their resources, and so they were being scheduled in a cluster with no attention paid to how much resources they may use, and they were all sort of competing with each other over CPU, memory, and I/O. So we as a community moved to making sure that all of the merge blocking and release blocking jobs for Kubernetes declared their resource limits and their resource requests explicitly. The next two things were to make sure that all release blocking jobs run in a dedicated cluster where only jobs that declare resource requests can run. And we did the same thing with merge blocking jobs. Those are both still in progress. The reason they are still in progress, as far as I know, is that the Bazel build and test jobs and the build jobs have not been migrated over. The reason for this is because I really wish I had this link somewhere. Maybe I do. I do not. I'm going to find it. But basically, these jobs write to a Google Cloud Storage bucket called Kubernetes release, or Kubernetes release dev. And that bucket lives in a project called Google Containers. Let's see if I can find it here. Here we go. So the bucket lives in a project called Google Containers. There is no, that project has a restriction that only google.com accounts can write to this bucket. And part of what we've been doing as we move the jobs over is to move them to a community-owned cluster that lives in the Kubernetes.io Google Cloud organization. So I've gotten as far as proposing that we use alternate buckets. Boy, there's really just no comment here that cleanly describes this. Over here, nope. Anyway, basically, release engineering needs to help us out here, and they have not had the time because they were heads down on 119. Now that we're early in the 120 cycle, I would like to see us push for this. This is going to require kind of a slow migration of jobs from one bucket to the other. It may involve setting up a canary job that pushes to the community-owned buckets in parallel, and then gradually we can update job definitions to consume from the new community-owned bucket instead of the old Google-owned bucket. So as far as I know, that's the only thing that's really holding up all of the build jobs. We were also experiencing some fun in migrating the so the situation with merge blocking jobs is much better. We have many of them migrated over. The ones that are not, let's see, well, this is a lie. That's actually been migrated over. This gRPC job, if I remember correctly, is an example of why it's difficult to mess with a job if it's already kind of flaky and failing. We basically found that the job intermittently fails or times out for whatever reason. So if you're just looking at, right, this is all of the runs of the job over time. Higher up is later, lower down is earlier. And so it's kind of tough for me to tell when something changed related to this job and if things got better related to this job. I mean, okay, there's a big block of red down here. So maybe if I go earlier, okay, there was a lot of failure. But I think this was related to a job configuration issue. So anyway, I think we need to, I think this job is failing as badly as it was before, so we haven't made things worse. So I'm probably ready to call this particular issue closed. I just want to actually, I think we need to get some time on that. The other jobs are related to, the other complications are related to Bazel. So Bazel in the google.com owned cluster uses a feature called RDE, or remote build execution, where it ships the actual Bazel tasks and stuff off to some other pool of machines or something. This is an alpha feature that is not available to us on the community-owned clusters. So this is partially like both migrating away from RDE to running the jobs on cluster, as well as migrating the jobs to the community-owned cluster. This has basically been done for Bazel test, but as you can see, I started to see like a lot more failures seemingly, and the duration went way up. It turns out RDE gives you a vast amount of resources to run like as parallel as possible. The way we're simulating kind of similar resource usage on the build cluster is to give this job 7 CPUs, which is a lot of CPU. All this job is doing is running unit tests twice. This part was 3 times, this part is twice. Because this was also related to Liget kind of pushing us to notice that back here in these times, the job was running unit tests 3 times, and if it passed one of those 3 times, it considered the test passed. When we stopped doing that and instead required the tests to pass 3 times in a row, we uncovered that our unit tests are also flaky, just like our end-to-end tests. We've made great progress on deflaking that, but things are still a little flakier than before because we've actually uncovered that our unit tests are flaky. So this is a similar situation where it's tough to tell if things were appropriately green or not beforehand, and if we're making the situation worse or better, or not having that much of an impact, but that's a good thing. And it's the same story with Bazel build, with the Google Cloud Storage bucket issue and RDE. Between those top 3 were considered the most urgent and important things to get done. So there's a bunch of other stuff that I feel like we could get community help with if anybody is interested. We kind of decided once we had taken care of the permanent critical jobs that we were, and I am not actually sure how I'm going to get out of screen share here. This is great. Let me stop sharing just so I can see your faces for a second. Ah, that's better. I feel weird talking to a blank screen, a bunch of windows. So that was taking care of the critical jobs. The next part is to like ask everybody, hey, since you're getting the benefit of using community resources to run CI, please make sure it actually passes. And please make sure you're actually declaring your resources. And so what we need help with is identifying and implementing a policy that says, hey, if your job is failing for some arbitrary threshold, let's say like if your job is failing for 4 weeks in a row, we probably shouldn't be running that job. That's probably a waste of community resources. And so luckily we do have queries to identify how long jobs have been continuously failing. So we could use those queries to identify the list of jobs we could go after as humans. The trouble is we may not necessarily know who to contact to say, hey, your job is going to get deleted. And so there's another issue about, hey, if you're going to use community resources, you need to put contact info for your job, which basically means you need to set up a test grid alert for that. And we can probably make a really good guess at who should own which job based on what test grids the jobs already show up in. So I'm pretty sure if somebody was handy with YAML or JQ or YQ or something, they could come up with a report that kind of makes a best guess at assigning everything. And then we could probably blast out a notification to Kubernetes dev and tell people like, look, your SIG is getting this job. If you don't want it or you don't agree with it, please comment on this PR. We already have tests in place to enforce that jobs in the release master blocking dashboard have contact info. So it would just be a matter of changing those tests to look at everything. And I believe that issue is tagged as help wanted on our board. So that's the bulk of what I have as far as where we're at on progress. I feel like I've been talking nonstop, and if you haven't tuned out by now, you are paying way more attention than I would as a human being. So I'm just going to pause there and ask if anybody has any questions or comments.
Would it be beneficial to even, in that case, open a PR automatically to basically disable these jobs? And basically ping the contact person once that is in place? Because then we basically have a board for discussions already saying like, hey, I need this because of this and this, or I'm just doing work right now, or yeah, fine, delete it.
Yeah, I'm inclined, I mean, the when we were back in August or July and things were really bad, I would have been more inclined to be draconian about this and say everything's getting shut down, and then let's see who comes screaming out of the woodwork to claim their jobs. I think things are not quite as critical as that. So in order to be a little more collaborative or cooperative, I feel like it's better to give people a heads up and say, like, look, we're making these, like, you have until this date to claim your job. And if you don't claim it, we're deleting it. We could get into the business of like, oh, we're disabling it, or we're scheduling it at a much lower frequency. But I also kind of feel like recovering things from deletion is what source control is for. And so as people are like searching around trying to find what jobs are doing what, it's better to just delete jobs if we're not actively using them. But I agree with your point that if people don't claim their jobs past a certain deadline, we're just gonna delete them. And I like your
I was more talking about the failing jobs that have been failing for a while, like not necessarily about the claiming part, but I guess that could work as well.
So the failing thing, I think we broke that up into 3 parts. The first part is like figure out, take a guess at who owns which jobs. And then the really permanent, look at the really egregiously failing jobs. So I think everybody's eyes popped out of their heads when I talked about how we had a job that's been failing for 700 days in a row or something like that. So there is an issue. If anybody wants to, go take a look at the list of jobs that are failing and delete the really permanent failing ones. That sounds great. We should give a shout to like Kubernetes dev to give people a chance to claim these and say, no, please don't delete that. And then we'll know who owns it. But yes, I am a fan of like, let's stop the bleeding. It's pretty obvious that there are some jobs that are wasting resources and will never be paid attention to. But there are a lot of other jobs where maybe it's less clear whether they're necessary or not. And I think that having humans sweep through and do this is great and all, but I think the policy is really only going to be adhered to if there's automated enforcement of this. So the closer we could get to having a bot kind of, by having the contact info encoded in the job, and since the bot sort of knows how to query which jobs have been permanently failing, it can sort of put 2 and 2 together and notify that email address and say, hey, caution, if you don't do, you know, if the job has been failing for more than 100 days or more than 4 weeks, I'm going to open a PR to delete it.
Wouldn't it be better to change from email address to GitHub user? Maybe.
Well, maybe. Unfortunately, at the moment, like email address is the one way we have of doing contact info.
Yeah, I saw in the test script definition, I think you can only specify email address for maintainer.
Right. Because yeah, to add other contact info, that sounds really cool if we want to propose that as a feature. But I feel like rather than blocking on the presence of a feature which may or may not get implemented, I'd want to sort of work with what we have. But yeah, because like I think
we already have capability to send out emails from Prow.
At the moment, we do not have Prow set up itself to send out emails. We do have, there is a Slack reporter, which I believe can be configured to send out alerts to different channels based on the repo that those jobs are configured.
Yes, but you would still have to make the connection to whatever the email service on GCP is to send that out, right? Or like SendGrid or something like that.
So the idea is we would lean on TestGrid sending out email. Oh, I got it. I see what you're saying. Yes, okay, that is very correct. Having a bot do this we need to make sure the bot could actually send an email. Now I see what you're saying. That's very fair. Yeah, I'm not sure what to do about that.
The way in is like, is it more work to get this email connection working, or is it more work to get like a GitHub feature, like notifying a GitHub user basically? If we get the notifier bot to basically assign task to someone.
Right.
Uh,
Um, yeah, that's really fair. I think I'm wary of assigning tasks to individuals, just because uh, they may or may not be present. Um, I think though we could try like um, we could try using GitHub Teams. Like I think every single SIG is required to have a GitHub team that's named after the SIG, and so we could make an educated guess based on which SIG named dashboard a test belongs to. We could construct the GitHub team name that way, and then we could ping that team when opening up the PR, something like that.
and the SIGs have SIG mailing list, right? So the email would also work in that case for a SIG.
Correct. And I think that's the intent of like leaning on TestGrid to do this sort of stuff. And TestGrid also provides the capability to send out emails if a job has been continuously failing for more than blah. That can be configured on a uh, per job basis. That's that. Um, the other thing, for what it's worth, for me personally, that bugs me is like we all agreed that this was really important and bad. Um, and now there was discussion in SIG release about lifting the 120 milestone restriction because I guess things are better now. But I really wish we had like metrics or graphs or something that showed us that, the tests are this flaky or CI is this bad. And I'm not sure that we have that at the moment. So we have another issue open for like try and identify some metrics or stuff that we could use. And I'm really open to like any and all brainstorming ideas people have on this. I'll go back to talking to Windows for a second to share some of the stuff I've got. Um, so if I click through on the issue, to find metrics and reports that allow us to track whether the situation is getting better. I tried to lay out, how we were experiencing pain and different ways that we could maybe try indicating that with metrics. Theories on how that, like what's causing that pain, and if we could use metrics to show that. So let's see, what other stuff. Here's a list of all the possible data sources I am aware of that we could scrape from or grab metrics from or something like that. So things like, cloud monitoring dashboards of the Proud build cluster that the community owns, so we can see how that cluster is doing. So if you're a member of the Kate's Infra Proud Viewers group, it's in a YAML file in the Kate's.io repo. You are all welcome to pull yourselves in. You can see this dashboard. Here, I'll sign in as my personal account just to prove like this account doesn't even have a Google, I don't pay any money or anything on this account. I just have an email address and I can still view things if the dashboard ever renders. And so I've been trying to take a guess at like what sorts of things are helpful for us to understand, is our build cluster healthy or is it overly resource constrained? Things that have been helpful in the past are these top things here. They show when I/O is getting throttled, either due to CPU usage or network usage. The problem is these all look really noisy and peaky and stuff. None of them are related to actual bad behavior. To show bad behavior, I might have to go a month back. Um, do, do, do. Yeah, it's not being super helpful, so I'm going to stop talking about that. So I've also got graphs that show the total cluster capacity in terms of memory and in terms of CPU. You can see that that grows elastically because we have auto scaling set up for this cluster. We've also, and so here you can see the size of the node pool that's scaling up or down. You can see we get really peaky, like we've gotten as high as having 120 nodes available all the way down to having like 27 nodes available. There's something around like 11 a.m. Pacific seems to be a pretty high traffic time. You can see that this way in terms of the different pods that are present in the cluster. So jobs all get scheduled as pods in the test pods namespace. So here are the total number of pods in the cluster. Here they are broken out by the job type. So here are the, you can see the periodic jobs at a pretty healthy clip. Pre-submits are super peaky and often will, there will be more load from pre-submits or pull request jobs than there are from the periodics. Down here, it's broken down sort of by pull request. So you can see the text is probably really small, but so the Kubernetes 94.196 has had 37 jobs in the last, in a 1 hour interval that this graph is sampling over. So somebody probably hit retest a lot or pushed a lot of commits repeatedly or something like that. And so if things start to tip over or we feel like there's excessive resource consumption, we may be able to find whether there are culprit PRs or whether there are just a lot of PRs all happening at once that impact us.
Would that count the jobs that if you say pushed commits repeatedly, if I know that Prow is canceling some jobs when you push it like within a minute. Would that also count towards the canceled jobs?
It does. It counts the canceled jobs. So that's why, like, if I go down a little more granularly, now we're looking at a 5-minute interval. There was a period of time where, yeah, supposedly this counted 36 pods. I'm like, when we start to get down to that super granular level, I'm less aware of whether this really means there were 36 pods running simultaneously. Or like 36 containers all running continuously, or whether there were 36 pod resources visible to the cluster in some shape or form. Like this doesn't necessarily, if I recall, I don't think this has the capability of segmenting by the different pod statuses. It shows, yeah, it just shows all pods. I'm wondering, let's see, can I filter by like pod status? Not really. So it could be that I'm seeing a lot of like canceled pods because Prow will abort pull request jobs if a new commit is pushed. And these sort of just get deleted over time eventually by the syncer component of Prow. The other handy thing on the dashboard is breaking it down by job type, so we can see whether maybe a configuration has changed for a particular job, or maybe something about that job's resource consumption is causing it to behave oddly. It's basically the scalability jobs, the 100 node pull request jobs. They tend to hang around for a while because they take basically the longest, I think. So this is one dashboard we can use. My concern is like, it's a lot of graphs and I'm trying to sit here and read the tea leaves in front of y'all. I'm not confident enough in any one of these things to say, let's try and set up alerts on this. I feel like this is more like just humans have something else to look at, which they should. I'm glad we have it. Another way to look at this is from the prow control plane point of view. So Plank, as some of you may know, is the component of prow that's responsible for turning a prow job into a pod. And so this dashboard here allows you, it's got 3 graphs to group, so this dashboard here shows the prow job resources that Plank is acting on. And you can group by 3 different metrics. In this case, the dashboard's set up to group by the prow job type, the state of the prow job, and which cluster the prow job is scheduled to. And right now I've got it set down to only look at prow jobs that hang off of the Kubernetes repo. So as a result, I can see that these were the before times. This is when everything was really bad. This is when we were running way too many jobs way too many jobs, period, probably. And certainly way too many jobs for the resources we had available for these jobs. So just the sheer shape of it, you can see that the number of pre-submit jobs is way, way larger than anything else. These are not necessarily, you shouldn't look at these as discrete events because these are graphs of the prow job resources. So it's possible for a lot of prow job resources to get created and then to just hang around. Even though like the containers or pods that ran these prow jobs got deleted a while ago, the resources are kept around until something called Syncer goes through and cleans up the resources. And there's a balance between keeping enough of these resources around to be able to do reporting like this versus we don't want to have like 50,000 prow job resources that we're continually listing with our controllers to act against. Anyway, so we discovered during the bad times that prow jobs that couldn't work for resource issues ended up in the error state. So if I look at the prow jobs by state and click on the error graph, I can see that yes, we had a really bad time during code freeze. And yes, things have gotten substantially better since we switched prow jobs to explicitly declaring your resources, and we moved prow jobs over to a cluster that scales appropriately based on those resources. So here, I think I can say things have gotten a lot better. In terms of measuring like how far we have to go, so this is broken, this does not break down by jobs, right? So this is all pull request jobs and all periodic jobs. This is the number of jobs that run on the google.com default build cluster. And then this yellow line here is the number of jobs that run on the community-owned K8s prow build cluster. And you can see like over time, we've added a lot more jobs to the point where we're actually handling more jobs on the community cluster than we are on the google.com build cluster, which is great. But I feel like we're not really going to be fully done until we've migrated this green line all the way down to 0. Anyway, those are the things I have for metrics at the moment. Something else I've been noodling on personally, y'all may remember Velodrome, which was sort of a Grafana instance that was driven by, there's an InfluxDB instance that we stuffed query results from BigQuery into. And I had created sort of a merge blocking and release blocking job health dashboards. And we ended up having to kill off Velodrome for security-related reasons. I haven't had the bandwidth to go back and really work on that. I've started iterating on just standing up the latest and greatest Grafana on my own system, and then setting up a BigQuery data source. So just talk to BigQuery directly to see if I can sort of recreate that. I feel like if I get far enough with this, we could investigate whether, we could replace Velodrome with this, see if the security is any better. I haven't quite gotten as far as would workload identity work with this, or do I need to upstream some changes to Grafana to get that to happen? But I'm showing the job data over the last 6 months. And so again, we can sort of see like the number of jobs that were triggered for merge blocking jobs climbed up substantially over time. and then fell down. So this is both PR traffic going down and us deciding there were certain jobs that we no longer wanted to execute. Trying to look at the daily failure rate of jobs looks super noisy, because some jobs go from being perfectly fine to failing 100% of the day because they don't fail that much. But you can sort of see that the failure rate kind of climbed up for all of these jobs, and it's kind of gotten a little more tightly coupled down below, aside from jobs sort of periodically peaking up and failing 100% of the time. I would quantify these as like jobs that aren't triggered that often, so the variability is really high. I've also been trying to take a look at the duration of the jobs, seeing if that's improved over time as we've migrated jobs over. I'm trying to scroll here. So just looking at the 99th percentile, 75th, and 50th durations, things are kind of getting better. The top of this graph is 2 hours. Nothing should take more than 2 hours to run, especially if it's a pull request job. And our times have improved. I wanted to call out the verify job has gotten a lot better. I think, I forget what his actual name is, but Hashed Dan, when he was doing CI signal for 119, managed to improve the verify job's execution time. And that really shows here, which is really cool. Especially if you start to look at like the 75th percentile or the 99th percentile, like it's all gotten a lot better ever since he did that change. So I feel like metrics like this might be really helpful. This is me just playing around with other panels. So that's all I've got on that. I really feel like I would love anybody's help or brainstorming on what we should do. What's the issue? With, actually querying other stuff and figuring out the right metrics that say, yes, we are doing good, or no, we are not. I think like test grids offers some stuff. Like we can see that jobs are flaky here, but I can't necessarily see how flaky they are. I could kind of go with these numbers, but then I can't necessarily see how these are changing over time. So it may be difficult for me to know when we did this change at time X, we saw this effect on the flakiness, and thus we did the right thing versus the wrong thing. But again, I'm talking a lot, and I can't see your faces, so I'm going to stop. Yes, that's all I had. Does anybody have a chat about?
I have another topic. A while back, I was talking about how we have Prow installer in Kima. And I think I think Eric saw it again when someone was asking on, I believe it was Prow Slack, about how people are installing Prow. And I just want to see if there's an interest that we push this upstream. It's missing currently everything around the S3 bucket stuff, so Amazon hosting. We haven't done that because we're running on GCP as well. So what the gist of this is basically getting Prow up and running without you touching GCP service accounts yourself. Like if you follow the installation instructions, is apply this YAML, create a service account here, apply this YAML, create a service account here. The installer takes care of that for you if you give it a service account. So like you literally are down to one service account and the rest of it is created. It creates buckets for you and everything with the right permissions, and gets you Prow running. I just wonder, like I just posted a link in the chat as well, if this is something that anyone is interested in us pushing upstream. We might have to spend some more work on the code itself, but once it's upstream, I guess we also have to think about adding the S3 stuff to it. for people that are interested in that.
I can't necessarily speak for Eric. He's more on the team that works on Prow, but I'm pretty sure they have a goal of making like Prow as easy to install as possible. And so I'm sure they would be interested on collaborating with you on this. Like I don't necessarily know that it needs to be 100% perfect before you get it upstream. I think getting it upstream and iterating on it would probably be acceptable. The thing that comes to my mind is there is something called Tackle, I think. I haven't used it.
Bazel, and that was the reason why we didn't like it, because
Oh, I
Bazel is
see.
very hard to use.
Tackle
And
was fully reliant on Bazel. Okay.
yeah, I think so. And like that was one of the main reasons why we said, hey, we want to do that ourselves somehow easier.
Well, I'm certainly a fan of finding a way to do this without Bazel.
So this is all Golang, just FYI. So we don't use any Bazel, and hopefully makes it easier to understand and install for you as well. So I mean, I guess people have to try it out and see if the code is okay. But I don't know if there's an issue already for this, like Prow installation, make it easier somewhere where I can start discussions on this. Or I'm also not sure what Eric thinks of it, because he saw it, but I'm not sure if he looked at it really.
Well, I'll point the team at that because I would expect Cole to have an opinion as well, and there's also just the fact that Google's going through one of its wonderfully internal focused periods right now, where some Googlers may be less available than others for just a few weeks more. But I think this aligns with goals. If we can get past the lack of Bazel or whatever, because that sounds fine to me. I think my other two questions from things I know Prow does lately perspective are whether this configures workload identity and sets Prow up to use workload identity. And then also whether this uses the sort of the automated webhook management feature that Prow now has.
No. I think we're not on these yet. So it's also a while old, because we set up our test Prow cluster. So we have one Prow cluster and one test Prow cluster that we run stuff with and test our upgrades and for our main production cluster. So this was, I think, like a May, April initiative. So it's pretty old in that case.
Yeah, I can't remember. Like webhook rotation. So what I'm talking about was somebody accidentally exposed Prow's HMAC token, and so we needed to rotate it, and we discovered we needed to rotate it like everywhere. And so we're trying to get to more of a point where you can have Prow automatically install a webhook on a GitHub org or a GitHub repo, and it can also automatically generate new tokens and rotate those out without you having to worry about that. So I feel like that might simplify the process of installing Prow somewhat. It kind of, I haven't looked at how your thing sets up webhooks, but I know not having
something for HMAC, but I think it's just the initial setup. I'm not sure we handle rotation, but we have a ticket somewhere for a rotation of that kind as well. I'm not sure if we're trying to get that into the installer itself.
Okay. I think it would, getting that included would would probably help a lot. We may still be in a situation where there are parts of Prow that can't function with workload identity at the moment. Like I know we're trying to, if at all possible, stop having a service account key stored in the cluster as a secret and instead just rely entirely on workload identity. But we may not be there yet. So I would view, yeah, and Cole would have more information about the webhook HMAC rotation thing. But I think it would be really beneficial if we could all decide on the best like one-click way to install Prow. We may not be able to. I don't know. There might be differences of opinion on how to best manage Prow going forward. And maybe some of those decisions affect how you choose to install Prow from the get-go. But I think it would really benefit all Prow users and certainly benefit all potential new Prow users. Like anything you can do to make it easier for people to try out Prow sounds good to me. I don't know.
Yeah, for us, it was mainly the need for like setting up test clusters easily for whenever I want to try something with Prow, I can use this and have a cluster up and running in, I guess, like 10, 15 minutes, just pointing it at GCP. And then tearing it down next week if I want to try something out. I guess that was the main motivation for us. But definitely for new users, and I don't know how many people out there are actually having their own Prow instance that would be interested in something like that, or are developing features and need to have an installer to set up a Prow quickly. But Bazel Pane was the main motivation for this.
I hear that.
Cole definitely has some more knowledge on it. I know they're trying to do something like a declarative in-cluster version of that deployer. So you might be able to work with him.
Okay. Well, that sounds really cool. Thank you for sharing that. Anything else? All right. I guess that's our Tuesday. Thank you, everybody, for showing up. I hope you have a great rest of your Tuesday. And until then, see you later.
Thank you. Good day.
All right, have a good one.